next one, and that is by Maria Racca, and it's analyzing the effect of 4 preservative treatments on the oocyte size of Mediterranean sardine and European anchovy.
Okay, good evening from me. My name is Maria Racca, and I would like to present the work that was made during my pre-graduating thesis in the Aristotle University of Thessaloniki. And its title is Analyzing the Effects of 4 Preservative Treatments on Oocyte Size of Mediterranean Sardine, Sardina pilchardus, and European anchovy, Engraulis, encrasicolus. And let's start with some background information. The estimation of fecundity requires processing and preservation of ovarian material. Though this ovarian material can be affected in various ways by preservation treatments, preservation treatments can decrease or increase the weight of the gonad or the oocyte size in various ways, as already referred in the bibliography many times. Although little is known about this effect of preservation on oocytes of different stage and shape. Concerning all this background, our objectives in this work were to compare the short-time effects of 4 different preservation treatments on the size of oocytes of reproductive active Mediterranean sardine and European anchovy. And why we choose those species is because sardine and anchovy have spherical and elliptical oocytes respectively. So if we want to check the effect of the shape of oocytes on the effects of preservation treatments, we thought it's the best way to choose these 2 species. And we continue with our methods. Our sampling took place in northern Greece, in the Bay of Thermaikos, and took also place several times in the reproductive seasons of the 2 species, as we can see in Table 1. The samples were transferred to the laboratory, where measurements of gonad weight, total weight, and length were made, and afterwards our samples were grouped according to the stage of ovarian development. As we can see in Table 2, we had 3 groups, one of early vitellogenesis, one of late vitellogenesis, and one of final oocyte maturation. After the grouping of our samples, we extracted the gonads, and we took 4 samples of each gonad. The samples were stored in 4 different solutions: alcohol of 25%, 50%, and 70%, and buffered formalin of 10%. In order to take the data for oocyte size, we followed an automated method which consisted of 3 main steps. Preliminary laboratory processing of ovarian samples, mainly included by separating the oocytes. Then digital photography using an adjusted stereoscope camera, and processing the images to calculate the oocyte size within a routine that was developed within the program ImageJ, which is a freeware program. In details, for the species of Sardina pilchardus, we used an automated method consisted of 4 steps. First, converting the image to an 8-bit black and white image, thresholding and watershed commands to separate the oocytes, and then we had the size measurements. We alterated a bit this automated method in order to deal with the very specific shape of the oocytes of the anchovy. And in details, the automated method was opening the file with ImageJ, cleaning the background using the command of subtract background, convert again the image to an 8-bit image of black and white. In order to segmentate the oocytes, we used the plugin of watershed segmentation, adjusting the radius from 8 to 12, and also the watershed from 120 to 180, in order to be able to separate the oocytes. And then, of course, we had again data of oocyte sizes. In order to get the mean size of every spawning batch, we use the Bhattacharya's method within the program NormSep that is provided by FAO in order to analyze the size frequency distributions. Our measurements were repeated every 1 day for the first 7 days after sampling, and the measurements continued for a month with a frequency of 3 to 5 days. And we go on with our results. We can see here three figures in which we clearly see how the size increases, how we, when we go from the first to the third group, from early vitellogenesis to the final oocyte maturation. According to our analysis of covariance, there was a significant effect only for the two treatments 3 and 4, which correspond to the alcohol 50% and 70%, and there was not a significant effect for the first two treatments, formalin and alcohol, of 25%. And also the treatment 4, this of alcohol 70%, had the greatest effect. Further analysis of covariance concerning the ovarian developmental stage showed that there was not significance in the intercepts, which is logical as we have three different groups, but there was not a significant relationship between the three slopes, which means of the effect of the treatments 3 and 4 was the same for the three developmental states, and there is no allometric effect with the oocyte size. Concerning the effect of space, which we checked comparing the two species. Again, according to the analysis of covariance, the slopes did not differ significantly between the lines of the two species, which means that, again, there was no allometric effect of the oocyte shape on the effects of the preservation treatments. Another very important result was that the relationship between the size and the days was not linear, as the main shrinkage was developed the first days of the preservation. The oocyte size after 30 days of preservation decreased from 19.1 to 46.7 for alcohol 50%, and from 24.9 to 34.1% for alcohol 70%. Also, there is a change in the quality of oocytes, as we can see in these two images. In the day 1 and day 29 after the treatment, after the preservation with the treatment of alcohol, we can see that there is also a change in the shape and in the morphology of the oocytes. And let's make some conclusions. The greatest effects were caused by the alcohol treatments of 50% and 70%. The effects did not vary according to different oocyte states and oocyte shape, which was the different species that we had. The main change in the oocyte size took place the first days of the implementation of the treatments. And from those tested, the recommended ones would be the formalin of 10% and the alcohol of 55%. But also we have to take more factors into account, like health issues. We already know the conflict about the cancerogenic aspect of formalin, and also long-term preservation, as we are not sure that the alcohol of 25% can be used for long-term preservation. Thank you very much.